Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So we are discussing engineering typology subject. The course code is AMEC 24. So today we will discuss about theories on friction. So in this topic we will learn what are the various theories are there about the friction, and what are the various measuring methods, and then what is the importance of friction in engineering typology. We will see one by one. The first topic is theories on friction. Already in previous sessions I have discussed about typology concepts and what are the important parameters involved in typology subject. So mainly friction, wear and lubrication. These three are important parameters in engineering typology. So whenever two components, two bodies or two surfaces are in relative motion, there will be friction, there will be wear, and that's why need lubrication. So that the engineering typology involves these three concepts. So theories on friction plays important role in find out the friction and selecting the materials. So why? Because we should know the friction properties and various mechanical properties of the material before selecting the material. So whenever you are designing a component or mechanical element, you should know about properties of material. So then only your design will be success. So that you should learn the theories on friction. So already you know, if friction is a statistical parameter, it depends on a number of variables. So there is a need to understand science of friction. Already I told you, you should know about friction. What is the back-end theory of the friction? To understand the effect of material wear, so which components are in contacting? So the two components are in relative motion. So which material components are in contact? You should know the material properties to understand the effect of material wear. And then what is the role of lubrication? So some cases there is no need of lubrication. In some case the lubrication is required. Example, dry friction and wet friction conditions. And the environmental factors are important in dry friction. The dry friction means it is also known as solid body friction. And it means that there is no coherent liquid or gas lubricant film between the two solid body surfaces. So whenever there is no lubricant present in between two surfaces, that the contact of air is said to be in dry friction. Whenever lubrication is present between two contact surfaces, it may be minimum film thickness lubrication or hydrodynamic lubrication properties, that may be called as wet friction. So that's why the dry friction is also called as solid body friction. So there is no lubrication, there is no wet contact between these two surfaces. Two are purely solid. So another important thing is here adhesion property. And here two mainly friction sources are there. One is adhesion and another one is deformation. So some force needed to pulp asperities of harder surface through softer. So some force is required to remove the material, to scratch the hard material, to pulp the hard material, that is asperities, irregular surfaces through soft. In lubricated tribophare case, friction due to adhesion will be negligible. While for some smoother surfaces, under light load conditions, deformation component of friction will be negligible. Here two conditions are there. One is adhesion, another one is deformation. In a lubricated tribophare, for smoother surfaces under light load conditions, deformation component of friction will be negligible. Deformation is negligible and adhesion is negligible in tribophare case under light load conditions. So in this figure shown the adhesion properties, it demonstrates the adhesion cold weld between two surfaces. Some force, that is you can say Fa, is required to tear the cold junction. Suppose you want to tear these two surfaces. This methodology is called cold weld. Some force is required, so then only the tearing is possible. So in previous case, you have seen adhesion. So the adhesion means mainly the contacting of surfaces. Two surfaces are in contact position. So that is called as a cold weld. In this deformation case, the deformation process, this figure shows a conical asperity approaching to a softer surface. To move upper surface relative to lower surface, some force is required, like here shown FD. So FD here means deformation force. To deform the surfaces, some force is required. That is FD. In previous case, adhesion FA. And FD, deformation. So the two friction surfaces are there. One is deformation, another is adhesion. So the resulting force is, what is the resulting force? How will you calculate the resulting force? The sum of two contributing force terms. So one is Fa and another one is Fd. The sum, the resulting force Fr is equal to Fa plus F. It gives resulting frictional force. So in the case of lubricated tribophile case, the adhesion is negligible. The smoother surfaces under light load conditions, negligible deformation. So the lubricated, if the surfaces are lubricated, then there is no adhesion, means the negligible. In smoother surfaces under light load conditions, there is no deformation, that is negligible deformation. The small deformation is there, but that is negligible. Here shown some conical asperity approaching. So suppose you want to deformate the surfaces, then apply some force in through certain angle and height. So the height, the surface height from its reference line. So how much deformated you can calculate. So what the theory, the first one is adhesion and deformation theory. We have seen the resultant frictional force, how to calculate. In this theory, based on the fact that all surfaces are made of atoms. So this theory is called as adhesion and pulping in friction. So in this figure shows the cold welding in steel and indium. The cold welding process is applied between two surfaces, two materials. One is steel, another one is indium material. So in this example, suppose this is a steel material and indium material. If you press the steel material over indium piece, so they will bind across the region of contact. So like this. So this process is sometimes called as cold welding. Since the surface stick together strongly without the application of heat. So no need here heat. Without heating the material, you can apply force on the one material. To press the material over another material. Due to the adhesion property of the materials, the two surfaces are stick together. This process is called as cold welding. So in this, the surfaces are made of atoms, means they attract over order one another by attractive force. So here seen the cold welding steel and indium process. So it requires some force to separate the two surfaces. So here shown the carbon graphite and stainless steel. Stainless steel and this one is a carbon graphite material. Need some force to separate these two surfaces. If you apply a sideways force to one of surfaces, the junctions formed at the regions of the real contact will have to be sheared if sliding is to take place. So whatever you apply force to do this is the frictional force. So in figure shows carbon graphite material adhered to stainless steel shaft. Due to some application of force, this will be happen. One material adhered to the stainless steel shaft. Here two materials shown. One is carbon graphite, another one is stainless steel. Next theory is theory of adhesive friction. So this theory developed by Bowden and Tauber. So what is this adhesive friction? As per this theory, an application of some force, that is W, the initial contact at some of higher aspirated tips occurs. The application of force, initial contact at some of the higher aspirated tips occurs. Due to high stress, those asperities suffer plastic deformation, which permits strong adhesive bonds among asperities. So whenever you apply a force on a material, then some stress will be developed. Due to this high stress, whatever the asperities are there on the surfaces, the all asperities undergone plastic deformation. So it leads to the adhesive bonds among asperities. Such type of cold formed junctions are responsible for the adhesive friction. So the real area of contact A can be estimated by, the real area of contact is A, can be calculated, estimated by applied load W and hardness of the soft material, that is H. So if as a shear stress of shear softer material, then force, adhesive force required to break these bonds can be estimated by equation Fa is equal to area into. Yes. So already you know the shear stress is equal to, that is S, is equal to load per area. So here applied load is adhesive force upon area, the real contact area. So that you can write Fa is equal to S into A or AS. By using this equation, you can calculate the adhesive frictional force. The coefficient of friction due to adhesive friction is given by ratio of frictional force to applied load. Frictional force Fa to the applied load, that is the coefficient of friction. So by using this equation, you may calculate the coefficient of friction. Next, in this theory, this figure shows the formulation and breakage of cold junction. So how it will be happen? The cold junction breakage shown in this diagram. Before breakage, the junction is like this. So applying force and applied some load, and then the adhesion will be happen, and breakage occurred at the cold junction. So in this figure, two surfaces are pressed together under load. Clear? The material deforms until area of contact is sufficient to support load, that is area is equal to W upon H. Here H is the hardness of the material. The material deformation depends upon this hardness of the material. To move the surface sideway, it must overcome shear strength of the junctions with force Fa. So already you know mu is equal to frictional force by load. So you can write in terms of shear stress and hardness. The word S is the shear strength and the hardness, H is hardness of the soft material. So these two values decides the coefficient of friction. So it means whatever properties of the other harder fairing material, the coefficient of friction would not change. So only the coefficient of friction will be changed due to the hardness and shear strength only. Whatever having remaining properties, it will not change. For most of untreated materials, the hardness is 3 times of the sigma y and the S is sigma y upon 1.7321. So here sigma y is yield stress. Yield stress and the expected value mu is 0.2. So that you can write mu is equal to S by H and the harder material, the hardness is 3 times of the sigma y, yield stress of the particular material. So here two types of material, treated materials, untreated. So that is, so treatment, some heat treatment process are there to improve the properties of the material, like annealing and normalizing, carburizing, like that. So without doing any heat treatment, those materials are called untreated materials. So you take normal simple material. So the hardness calculate. The hardness, how do you calculate? First yield stress, the yield stress of the material multiply with 3. Or otherwise, S is equal to sigma y by 1.732. But the most of the material fair, already shown in figure, the mu is greater than 0.2. So there is a lot of difference, the huge difference between the measured values of friction coefficient and estimated by theory of adhesion. So the whatever you measured practically, that value and the estimated some value you assume are estimated by theory of according to the theory of adhesion, there is a lot of difference between these two values. So here shown friction coefficients for various material fields. The theory is unable to estimate different coefficient of friction for steel on indium and steel on lead alloy. The theory related to deformation needs to be explored. See here the object sitting on a flat surface. So the object is this one, and then object sitting on a flat surface. Normal force is weight of the object. The here normal force is equal to mg, weight of the object only. But if friction acts downwards on the object, the normal force is greater than the weight, not equal to weight of the object. So whenever the friction acts downwards, so shown in this diagram. that is mg plus f sin theta. If friction pulls upward, acting upwards on the object, the normal force is less than the weight. So that is W minus F sin theta. So based on this, based on this friction coefficients values, you may be calculated. So one is object sitting on a flat surface. There is no here there is no difference between the normal force and weight of the object. Equal W is equal to mg. Whenever the friction acts downwards, there is a difference. The normal force is greater than the weight, so that the normal force, the mg plus f sin theta, by using this you may calculate. Similarly, third one, if friction pulls upward on the object, the normal force is less than the weight. Next one, friction due to deformation. Up to now, we have seen friction due to the adhesion property. Friction due to the deformation. This theory is based on the fact that contact between tribophare and only occurs at discrete points. So where the asperities on one surface touch the other. So whenever asperities are touch another material, so there will be only this contact occurs between these two surfaces. So the slope of asperities governs the friction force. So the sharp edges cause more friction compared to rounded edge. The sharp edges always gives more friction compared to the rounded edge. Suppose you see in this object, this is sharp edge. So here it gives more friction due to the high stress concentration compared to the round edge. So suppose here some fillet is there. When compared to this one, here more friction will be generated. Why? Because here less stress concentration will be possible and more stress concentration will be occur. So the expression for coefficient of friction can be derived based on the pulping effect. You may derive the mu equation based on the pulping effect. The pulping occurs when two bodies in contact have different hardness. It occurs only whenever two surfaces having different hardness properties. See, in this diagram shown, the deformation theory, the asperities on the harder surface may be penetrate into the softer surface. We have taken conical shaped object. The asperities of harder material shown. Some deformation force is required. So this surface may be penetrate into the softer surface. The softer surface is this one. So due to this penetration, produce frictional force. If there is a relative motion, the friction will be possible. So though that the frictional, the penetration into the softer surface governs the frictional force. So in this diagram, you may write the parameters 2R and H hardness of the material. So by using these parameters, you may derive frictional coefficient mu. So these are the references I have taken. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.